Can you see the screen, Rishikesh?
Yes, ma'am. Yes, ma'am.
First thing first, in your syllabus you are having polynomial, and there the polynomial chapter starts from here, that you have already seen algebraic expressions in your previous class. So if I'm writing 2x plus y, this is one of the example of an, okay, this is an algebraic expression, yes or no?
Yes, ma'am.
Okay, if I am writing let's say xy plus x square plus 3xz, this is again one of the example of algebraic expression, right?
Yes, ma'am.
Now the next part, that is polynomial is, okay, it came from it's just the extension of algebraic expression only, but there are some condition which needs to be fulfilled, then only we will be calling that particular algebraic expression as a polynomial. So if I am writing Rishikesh x plus 1 by x, is it a polynomial?
Yes.
Is it a polynomial? Actually this is not a.
No, it's not. It's not a polynomial.
Why?
Because in order to be like for an expression to be a polynomial, the power of any term in the expression should be a positive whole number. But here, 1 by x, if we convert it into x, like if you want to change it into x, it becomes x to the power minus 1, which makes the power negative. So it should be a
Okay, it's not a polynomial, because there are two conditions which needs to be fulfilled to become a polynomial, and the first criteria is one variable has to be there. So the examples which I was giving initially for algebraic expression xy plus x square plus xz, here three different type of variables are involved: x, y, z. Okay, we need one variable. Now when I'm saying one variable, a student always have the confusion that if I am writing let's say 2x square plus x plus 20, okay, here one variable, that is just x is involved, right?
yes.
Okay, yeah, like the first term containing x square, next is also containing x, but actually one type of variable, one alphabet we can see, that is x, that's called one variable. So one variable has to be there. Actually the name of the chapter is polynomials in one variable. Okay, but in future also whenever we'll be talking about polynomials, that means polynomials in one variable only. Making sense?
Yes, ma'am.
Okay, even if one variable is mentioned or not mentioned, by default it has to be one variable only. And the second condition is exponent of each and every variable has to be a whole number. It has to be a whole number. The way you said that, yeah, this 1 by x, which will contain x to the power minus 1, and the exponent of the first x is 1, it's a whole number. Next exponent of x is minus 1, not a whole number, so this is not a polynomial, right?
Yes, ma'am.
Okay, if I am writing under root x plus 25, is it a polynomial, Rishikesh?
X plus 25, right?
Root x plus 25.
Yes, it can be a polynomial because the power is whole number, right? Exponent is whole number.
Good
Okay,
evening, ma'am.
so if we will look closely, just a second. Yes, hi Nikhil. Just now we have started with polynomials over here. Okay, all the chapters after triangle will be continuing in our batch, and here we are going to take the previous chapters. Okay,
Okay, ma'am.
Thank
so
you.
yes, Nikhil, just now I have taken the identification of polynomial. So the example I have given on the screen is root x plus 25, and I was asking to Rishikesh that is it a polynomial? Yes, Nikhil, according to you, is it a polynomial?
Uh, yeah, ma'am.
Okay, so there are two conditions to be a polynomial. This two condition needs to be fulfilled. Any algebraic expression, if they will fulfill this two condition, which is written on the right side with pink color marker, one variable has to be there. The first condition is one variable has to be there. For example, if I am writing the algebraic expression, that is x square plus y square plus 2y, this algebraic expression is containing two different type of alphabet, x and y. That means two different variables are involved over here. This is not a polynomial. Okay, now if I am writing another example, that is x square plus 5x cube plus 23, here one alphabet is involved, that is just x, and hence it's a polynomial. Making sense?
Yeah, ma'am.
Okay, apart from one variable, okay, any algebraic expression containing just one variable doesn't mean that one time x will be there. It means one alphabet will be involved only. Okay, now the next rule, this two rule needs to be followed. Otherwise, if anyone is not getting fulfilled, we will say it's not a polynomial. So the second rule is exponent of each and every variable needs to be a whole number. Each and every variable, now listen to me carefully, I am telling that you have to focus on the variables. Here x is the variable, here x is the variable. Now what about the exponent of the first x? 2. Is it a whole number? Yeah. Next x, what is the exponent? 3. Is that a whole number? Yeah. Then it is a polynomial. Making sense? If I will write the example, that is x to the power minus 1 plus 23x. So we will check one variable is there. Yeah, all the variables exponent. So exponent of first x minus 1, is that a whole number? No, this is not a polynomial. Making sense?
Yeah, ma'am.
Okay, do you know these rules? Yes, do you know these rules?
Yeah, ma'am.
Okay, so the example which I have given, root x plus 25, I'm talking about this particular example which I had written over here, this one. Root x plus 25. I was asking that whether it is polynomial or not. So first thing first, rule number one variable has to be there. Is there one variable? Yeah.
Yeah.
Rule number two, exponent of each and every variable needs to be a whole number. Exponent of each and every variable needs to be a whole number, and the first x which is inside the root can be written as x to the power 1 by 2. Do you know that?
Yeah, ma'am.
Okay, root, square root can be written as power 1 by 2. Cube root can be written as power 1 by 3. Fourth root, okay, do you know that if you are having a square root of 5, you can write it as a 5 to the power 1 by 2. If you are having cube root of 5, you can write it as a 5 to the power 1 by 3. If you are having fourth root of 5, you can write it as a 5 to the power 1 by 4. And if you are having of, let's say, seventh root of 5, you can write it as a 5 to the power 1 by 7. Are you understanding?
Yes,
Yeah, ma'am.
ma'am.
Okay, so this root x can be written in the exponent form as a x to the power 1 by 2 plus 25. Now, the second criteria, that power of each and every variable needs to be a whole number. Here the exponent is not a, okay, here the exponent of it's 1 by 2, which is not a whole number. It is not a polynomial. Making sense?
Yes,
Ma'am,
ma'am.
ma'am, can you repeat 1 minute?
I said exponent of each and every variable. Whatever x you can see, whatever y you can see, just take a pause and check the exponent of all the x or maybe all the y in your polynomial. So if I am checking the exponent of first x, it was inside the root, which can be written as power 1 by 2. And now this 1 by 2 power, the exponent, it's not a whole number. Is that a whole number? 1 by 2 is a whole number.
No, ma'am.
Two rule needs to be fulfilled. The first rule is only one variable needs to be involved. You cannot have x, y, z everything. Okay, if x is there, only x needs to be there. Yeah, the power can change. Okay, x to the power 3, x to the power 4, all can be there. That is okay. Only one alphabet needs to be involved in your algebraic expression while checking whether it is a polynomial or not. Next rule is exponent of each and every variable needs to be a whole number. Making sense?
Yeah, ma'am.
Okay, here we have checked the exponent of x, and we were not sure how to check the exponent in the red colored highlighted part. Okay, but we here in first chapter, law of exponent you have learned, right? In
Yes,
number
ma'am.
system chapter, law of exponent is there, right? Okay, so from there
Yeah,
you must have learned, or if you have not learned, I am telling you that root 5, square root of 5 can be written as 5 to the power 1 by 2. Cube root of 5 can be written as 5 to the power 1 by 3. So these roots can be written in the exponent form, okay, by taking the power 1 by that particular root. If we know this property of exponent, then we understand that root x can be written as x to the power 1 by 2. And here the exponent of x is not a whole number. Hence, it's not a polynomial. Making sense?
yeah,
Yes, ma'am.
Yes, both of you. Are you understanding?
Yes, ma'am.
yeah, ma'am.
Ma'am,
Yes.
before that we are doing quadrilaters, right?
So second. Yes, quadrilaterals we are
Yeah,
doing in our actual batch. This extra class, uh,
yeah.
this is our extra class, okay, where we'll be taking the all the previous chapters which I have not taken with you, Nikhil, Rishikesh, and Ryan. Okay, there we'll be continuing with the progressing with the next chapters, quadrilaterals and all, and here we will every now and then our team will connect with you and will be arranging extra classes according to your availability, where we will discuss all the
Okay.
previous chapter quickly.
Okay.
Okay, so yes, today I have picked polynomials. Okay, and just now I was talking about the identification of polynomial. I must take few more example. If I am writing root 2x plus 35, is that a polynomial? One by one. Nikhil, is that a polynomial?
No, ma'am, because there is a root.
Yes.
Like,
Rishikesh, is that a polynomial?
Yes, ma'am, because the root is only on 2, and in order for it to be a polynomial, the power of the exponent should be, the exponent of the variable should be a whole number.
Okay. Ryan, what you are thinking? Is that a polynomial?
No, ma'am. I think it is no.
Okay, let's check. So rule number one, only one variable must be there. One variable means one alphabet needs to be there. Okay, only one alphabet. If only x is there, x x x, or maybe y is there, so y y y. So here one variable we can see x. Rule number one, okay, it's fulfilling. Rule number two says exponent of each and every variable needs to be a whole number. So whatever x or maybe y or maybe z you can see over here, the exponent of those x or maybe y or maybe z needs to be a whole number. Now I will underline this variable because I don't have to focus on the numbers. This 35, I'm not worried about that. Root 2, I'm not worried about that. Rule number 2 says just focus on the exponent of variable. Here the variable is this, and I will focus on the exponent. What is the exponent? What is the exponent? What is the exponent? Exponent is 1 over here. Can you see that?
Yes, ma'am.
Yes. Yes.
Nikhil, are you getting it?
yeah, ma'am.
Okay, and hence it's a polynomial. So when you have learned this chapter polynomial, you must be thinking that from where it came all of sudden. So now are you understanding it is just the extension of algebraic expression?
Yeah, ma'am.
Okay, let's move. Now be careful. The question will try confusing you. One time they will give you something like this, and another time they will give you something like this, just to confuse you. Okay, and you have to be careful. The first one, it's not a polynomial because only one variable is
T
involved.
to the power 1 by 2.
Yes, rule number one is true. Rule number two, t to the power 1 by 2. This root t means t to the power 1 by 2, and due to that, it's not a polynomial. But the second one, it's a polynomial. Clear?
Yeah, ma'am.
Okay, another example which may confuse you is they will give you something like this, that 1 by 2x in the denominator. Okay, plus 32, like this. Be careful, x is sitting in the denominator, and if you will bring it up, you must have learned in the chapter 1 law of exponent says that from the denominator, if you will take this x in the numerator, it will be x to the power minus 1. Okay, yeah, 1 by 2 we cannot do anything, but x can come in the numerator. Okay, 2 I don't want to bring it in the numerator. If I'll bring x in the numerator just to check what is the exponent. Now let me clear one thing. While checking whether the algebraic expression is polynomial or not, your all the variable needs to be sitting in the numerators part. Then only you can check the exponent properly. Are you understanding?
Yeah, ma'am.
Yes, ma'am.
Yeah.
This x will come in the numerator will be x to the power minus 1 plus 32, and the moment I am bringing this x from denominator to numerator, I can clearly see it's not a polynomial. One variable is involved. And rule number two, exponent of each and every variable needs to be a whole number. Here, exponent is minus 1. That is not a whole number. Clear?
Yeah, ma'am.
Yes, ma'am.
Okay, so these are the basics which is there in the first exercise. Now, the next part is how to identify the degree of the polynomial. I'm writing the polynomial. You tell me the degree. If we are having x to the power 5 plus 4, what is the degree of this polynomial? Degree.
5. 5.
Yes, Nikhil, do you understand degree means what? Ryan,
Yeah. Yeah.
yes, Ryan, do you know what does it mean? Degree means what?
No, I don't know.
Degree means the highest exponent of the
Yeah.
variable. Here, only one variable is there, that is x.
5.
Maximum power is 5, so that is
Yeah.
the degree. I am giving you another example for your clarity. If we are having 2x cube plus 5x to the power 7 minus 8x to the power 4 plus 22x to the power 8 plus 32, and if I am asking you what is the degree, degree means whatever variables you are having, the maximum exponent. This is the variable. Wait,
Yeah.
this is the variable, this is the variable. Okay, this one
Yeah.
is the variable, this one is the variable. Okay,
Yeah.
among these all the variable, I will check the exponent of each and every one. Okay, exponent 3, exponent 7, exponent 4, exponent 8. Maximum exponent is 8. Degree will be 8. Making sense?
Yeah.
Okay, so that's the meaning of the degree. Now if you are having, if I am writing just 2 and I am telling you first thing first, is that a polynomial?
No.
No, ma'am.
No.
Rishikesh, is that a polynomial?
Yes, ma'am.
Ryan, is that a polynomial?
No.
Okay, so this 2, law of exponent says that this 2, as you know, a to the power 0 is 1. Do you know a to the power 0 is 1?
Yeah.
Yes, ma'am. So it will be 2x to the power 0.
Yeah, 3 to the power 0 is 1. 20
Yeah.
to the power 0 is 1. Anything
Yes.
to the power 0 is 1. Okay,
Yeah.
so
Yes, ma'am.
law of exponent says that just write it, 2x to the power 0. That means 2 into x to the power 0. Just write it. Okay, because x to the power 0 means just 1. 2 into 1 is 2. So in our mind, we are thinking this 2 as this one. And then we are checking rule number 1. Only one variable has to be there. Yes. Okay, in
Yes,
our
ma'am.
mind,
Yes,
this is what we are thinking, and we have created it in our mind. Actual question was just 2, but we are taking it as a 2x to the power 0, or maybe 2y to the power 0. Now wait, is that allowed in mathematics? Yes, it is allowed, because x to the power 0 means 1, and I am not changing the question. Yes or no?
Yes.
Yes, ma'am.
Yes.
Okay, so 2 can be taken as 2x to the power 0. It's the same thing. It's the same thing. And this 2x to the power 0, rule number 1, only one variable has to be there. Yeah, one variable is there. Rule number 2, okay, exponent of each variable needs to be a whole number. Here x to the power 0, is that a whole number? Yeah.
Yeah.
Is it a polynomial? Yeah. 2 is a polynomial? Yes. 3 is
Yes.
also a polynomial? Yes.
Yes. Yes.
Minus 22, is that a polynomial? Yes. 5
Yes.
by 4, is that a polynomial?
Any numeral is a polynomial, right?
Any number, any numeral, any real number is a polynomial.
Yes.
Clear?
Yes.
Yes, ma'am.
yeah, ma'am.
Yes.
Okay. Now, if you understood, now the question will ask you, now tell me what is the degree of this polynomial 2?
0.
Zero.
0, ma'am.
Okay. So you will say the whatever you have thought. Okay, 2 as a 2x to the power 0, or maybe 2 as a 2y to the power 0. From here, you need to say the degree is the highest power of the variable, that is 0 over here.
Yeah.
Okay, another example I am taking. What about the degree of the polynomial 2 by 5? 0.
Zero.
Clear?
Yes,
Yes.
ma'am.
Yes.
Yeah, ma'am.
Okay, so let's proceed.
Yeah.
Degree, you understand. Coefficient. Now tell me, if you are having a polynomial, let's say 2x to the power 2 minus x cube plus 22. What is the degree? First tell me, degree you understand. First tell me, what is
3.
the coefficient of x cube?
X what?
X square.
X cube.
Minus 1.
X cube.
Yes, Nikhil, do you know what does it mean? Coefficient means what?
Ma'am, I need to revise it. I don't remember.
No worries. This is revision class. You don't need to revise it. In today's class, my target is to just revise, help you revising everything quickly. Okay. So coefficient means, let me tell you, coefficient means the multiplier, what has been multiplied with x cube. What is multiplied with x cube? Okay. So with x cube, I cannot see the number what is multiplied. So I'll be taking minus 1. Are you understanding?
Yes, ma'am.
Yeah,
If it will say what is the coefficient of x square? Coefficient of
Well,
x,
2.
it's positive 2. Okay. And if I say what about the coefficient of x to the power 4? So I will say
0.
I cannot see x to the power 4 over here. That means coefficient is 0. I
yeah.
cannot see x to the power 4 over here. Okay, maybe we can write 0 into x to the power 4, maybe. Okay, which we don't have to write. Okay, if you cannot see the term, the coefficient is 0. Making
Yeah.
sense?
yeah, ma'am.
Okay, so coefficient means multiplier. Coefficient means multiplier. What has been multiplied with x cube? Minus 1. What has been multiplied with x square? 2. Now the question will confuse you. They will ask what is the coefficient of x to the power 5, and you will keep on thinking, where is 5, where is x to the power 5? Just say it's not there. Coefficient is 0. Clear?
Yeah, ma'am.
Okay, so we are done with coefficient. Now the polynomial, how we represent the polynomial and how we find the values. So we do represent the polynomial like this. Px is equals to, okay, one more thing, according to the degree, the names of the polynomial.
Cubic linear quadratic.
Yeah, so when the degree of the polynomial is 0, just now we have seen the example 2. Here the degree is 0, And the name of this polynomial, the way you are having your name, Nikhil, Rishikesh, Ryan, similarly this type of polynomial, it's called as zero polynomial or constant polynomial.
Yes.
Okay, ma'am.
When the degree of the polynomial is 1, for example, if you are having 5x plus 3, here the highest power of the variable, highest exponent of x is 1, so degree is 1,
Yeah.
and the name of such polynomial is linear polynomial.
Ma'am, will we be doing questions on this?
Yeah,
Is this just a revision class or will we be doing questions?
just a second. Yeah, can you please repeat what you said?
Will we just like, is this just a revision class or will we do questions as well?
We will be doing questions as well. Okay, this is revision class. I'm trying to cover as much as possible. Then I'll open the book, will show you the questions, and you will see that we are done with the first exercise and the second one also. Okay,
Okay.
yeah, just when the degree of the polynomial is 2. For example, your polynomial will look like 2x square plus 3x plus 5. Okay, you can clearly see the highest power of the variable over here is 2. Okay, and the name of this polynomial is quadratic polynomial. Okay, when the degree of the polynomial is 3, it's called cubic polynomial.
Ma'am, a question.
Yeah,
Ma'am, normally in maths or any other branch, pi is called as 2, right? Then why here quad is known as 2? Because quad is known as 4 normally.
quad means 4.
Yeah, quad means 4, but here
Quad.
when the degree is 2, it's called a quadratic equation. Why?
Actually, quad means yes, quadrant. This word came, we are dividing in 4 equal part. Okay, why the name is quadratic? Somehow 2 and 4, okay, are related with each other. That's why the name is quadratic. And actually degree 4 polynomial over here, it's called quartic polynomial. Do you know quartic polynomial? When the degree of the polynomial is 4, the name is, it's qua. Okay, qua, and then quartic, and this is quadratic. Okay, so actually these names came from so many different reasons. The names in different language, it means that. Okay, in Spanish, in German, in French, it means that. And from the other terminology came, or maybe from Latin, the terminology came. Okay, so I'll see what is exact the reason. But yeah, these are the names, okay, given by our mathematicians, and we take it like this only. Okay, if there will
Okay.
be any proper reasoning behind that, from which language it has been taken, I'll let you know from which language it has been taken and what exactly the meaning of that. Okay,
Okay.
yeah. So the next one is 4x cube plus 25. Here the highest power of the variable, it's 3, and the name is cubic polynomial. Only this much you need to know, till cubic. Yeah, one more you can see, quartic polynomial. When the highest power is 4, the name is quartic, which is not there in your syllabus. You just need to know till degree 3. Okay,
Okay,
so
ma'am.
again I'm repeating, when the degree is 0, it's called 0 or constant polynomial. When the degree is 1, it's called linear polynomial. When the degree is 2, it's called quadratic polynomial. And when the degree is 3, it's called cubic polynomial. Clear so far?
Yeah, ma'am.
Yes, ma'am.
Okay, you
Yes.
wanted to take the questions. Let me show you the questions now.
Ma'am,
Yeah,
Can you also teach the long division method?
Yeah. Long division method you will be learning. Okay, we'll be doing factorization, and there for doing factorization of cubic polynomial, which is really confusing. You will be learning long division method, and it will be really helpful.
Okay, ma'am.
See the questions over here. No? Just read the question number 1. Which of the following expression are polynomial in one variable and which are not? Just now we have done, right?
Yeah, ma'am.
Next. Okay, let's answer. Let's do these questions quickly. First one variable is involved. Yeah. Okay, power of each exponent of each and every variable is a whole number. Yeah. Is that a polynomial? Yes.
Yes, ma'am.
Next, is that a polynomial? Yes or no? Only you have to say that.
Yes.
Next, is that a polynomial?
No.
No, ma'am.
No.
No.
Next, Ryan, are you getting it?
Yeah.
Next, is that a
What?
polynomial?
No.
No,
No.
ma'am.
Next, is that a polynomial?
No, ma'am.
No.
No. So many alphabet I can see over here. Only one alphabet needs to be there. And in mathematical language, we call one variable. Okay.
Ma'am, this is direct textbook question, right?
Yeah, what?
It's a direct textbook question, right?
State the reason wherever it's not a polynomial. Just a second. See, when it's a polynomial, we don't have to give the reason. When it's not, then we will be saying the reason that why it's not. Making sense?
Yes.
Okay, so the wherever I have written no, I need to write it in this form that it is t to the power 1 by 2 plus t into root 2. Here the exponent of t, okay, that is 1 by 2, okay, is not a whole number, hence it's not a polynomial. Clear?
Yes.
Next one, the 2 by y. The question is expecting you to show it. Why you said no? Just show it that it is 2 to the power 2y to the power negative 1. And again, the exponent is not whole number, hence not polynomial. The last one, if you are saying no, it's not a polynomial, write it. Okay, 3 variables are involved in this algebraic expression. It's not a polynomial. Clear?
Yes.
Yes, ma'am.
What is the coefficient of x square? First one.
Ma'am,
Coefficient
one.
Positive 1, right?
Yes, ma'am. Positive one.
one.
Next.
-1.
Negative
Negative one.
Next.
5 by
Positive
2.
pi by 2.
Pi by 2 is a number. Pi by 2 is a number. We will not get confused with it. Okay. Pi by 2 is the coefficient. Next.
0, ma'am.
0.
Okay. Number 3. We are not going to do. This is practical based question. Okay. For your exam, 1, 2, 4, 5 will be doing. Let's do. Degree. What is the degree of the polynomial?
Three.
Degree 3. Highest power of the variable, degree 3. What is the degree? Second.
0.
Yes, what?
Actually, 0 maybe.
Second one.
2.
Hmm?
It's 2. The variable is y. Can you see?
2.
It can be x or maybe y or maybe z. See, all the examples I have shown you with x, but you can have y as well, just like this. And this is again a polynomial. Okay, the
Yes.
way you are seeing this 2x minus 3 and you are really comfortable with that one, I want you to be comfortable with 2y minus 3. These two are same thing, just having
Yes.
different alphabet. Are you understanding?
Yeah, ma'am.
Yes. Yeah.
Okay, so 4 minus y square, variable
Yeah.
is y. Okay,
5.
degree is 2.
2.
Okay, highest power of the variable. Next one, third one, degree is
1.
1,
yes.
ma'am.
And the last one, degree is
0.
0.
0.
okay. Next one, 5. Classify the following as a linear, quadratic, and cubic polynomial. The first one. First, you will decide the degree and then you will name it. What is the degree?
Quadratic. 2.
Degree is 2 and the name will be quadratic.
Quadratic.
Okay, quadratic. Quadratic. Next one.
Cubic.
Degree is
3.
3. The name
Cubic.
is cubic.
Cubic.
Next one. Degree is
2.
2.
2, ma'am.
And again, the
Quadratic.
name is quadratic.
Quadratic.
Next one. Degree is
1.
1.
the name is linear.
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 Next one. Degree is
1.
1, ma'am.
name is
Linear.
Linear.
next one. R square. I want you to be comfortable with any alphabet.
2.
Okay.
2, ma'am.
Degree is 2.
2.
Name is
Quadratic.
Quadratic.
next one. Degree is
3.
3.
name is
Cubic.
cubic. Perfect. We are done.
Yeah.
Easy.
Yes, ma'am.
Okay, very easy. You already know all the concept. I am just helping you revising these. Let's move. Now the polynomials can be represented like this. Polynomials can be represented like px is equals to x plus 2. Till now you have seen polynomial like this. Now I am telling you, we can write the polynomial px is equals to x plus 2. Now this is not p into x. In the left hand side, we don't have p into x. Okay, we have a polynomial p. Okay, the name of this polynomial is p. The way you are having your name, Rishikesh, Nikhil, Ryan. Similarly, the name of this polynomial x plus 2 is p.
Yep.
Okay, and then in bracket it is written that variable involved over here is x. The name of the polynomial is p, and this p polynomial is containing x variable. Are you understanding?
Yes.
Okay, here p into x is not there. This is a way of representing it. Okay, this is just a way of writing it. P is the name of the polynomial, and in the bracket the variable over there is x. If we are having the polynomial r square, so I can name it like this. The name of this polynomial is q and the variable involved over here is r. This is how I can name it. Are you understanding?
Yes.
Yeah.
Okay. Similarly, if your polynomial looks like this,
Yes.
that means the name of this polynomial, which you can see in the RHS, is h. And the variable involved over there is y. Clear?
Yeah.
This is just one of the way of representing the polynomial. Okay. Now let's move. Whenever you are having this px as x plus 2, and if the question says find p1,
Pure.
that means you have to find the value of the polynomial when x is 1. You have to find the value of this polynomial when x is 1. Just put x equals to 1 over here. That's what this represents. Are you understanding?
Yeah.
Yeah, ma'am.
Okay, and you will be doing the calculation like this: 1 plus 2 is equals to 3. So P of 1 is equals to 3. That means, let me decode this language. This is mathematical language, and is trying to say, when the polynomial P, when you took x as a 1, when you took as x as a 1 became 3. Clear?
Mhm.
Yeah, ma'am.
Okay,
Yes, ma'am.
I can also write P of 0. Find it. That means find the P by taking x as a 0. Are you understanding?
Yes,
Yeah.
ma'am.
So
Yeah,
you
ma'am.
will do just like this: 0 plus 2 is equals to 2. Hence P of 0, the value is 2. Clear?
Yes, ma'am.
Okay, it's that simple. It's that simple. So here we are having number 2. Find P
So
of
what about number
P
one?
of 1. I'm coming to 1. I'm coming to 1. This is just another way of doing the same thing, number 1. But let me tell you what to do in 2. P of 0, P of 1, P of 2 for each one. I'm showing you the first one. Py is given as a y square minus y plus 1. Let me remind you, a polynomial P having the variable y is given in the RHS. Clear?
Yes, ma'am.
Okay. And you are supposed to find P of 0. P of 0 means just put y as a 0 in your polynomial and find the value. So when you will put y as a 0, y as a 0, you will be getting 1 as the answer. And we are done. Clear?
Yes.
Yes, ma'am.
Okay, now it says you are not done. You also have to find P of 1. So when we will find P of 1, same polynomial I'm going to take. The same original polynomial, Py is equals to y square minus y plus 1. And this time there I need to put y as a 1. So when I'll put y as a 1, y as a 1, y as a 1, okay, we are going to get 1 minus 1 plus 1. That is just 1. Clear?
Yeah.
Yeah, ma'am.
And similarly, we can calculate P2. Okay, for each polynomial, these 3 parts we have to calculate. Now let me come to number 1. Number 1 also is asking about the same thing. Find the value of the polynomial 5x minus 4x square plus 3 at x equals to 0. That means this time the coded language is not given, okay, which you learned just now. Simple statement is given that you are having a polynomial 5x minus 4x square plus 3. Now find the value of this polynomial when x is 0. That means you
Ma'am,
just need to put x as a 0. Yes.
ma'am. So, if it's not given in the in the coded form, we have to write it. It's like P of 0 equal to 5 into 0 minus 4 into 0 the whole square plus 3, like that.
Yeah, here we don't have to name it. Okay, directly we can say given this
Oh,
one,
okay, ma'am.
when x equals to 0, directly I can put the value. Okay, directly I can put the value when x equals to 0. Here I'll put 0. 5 into 0. Wait. 5 into 0 minus 4 into 0 square plus 3. So I don't need to write the coded language. This is simple, straightforward question. Okay, whenever the name of the polynomial is not given, you are not supposed to name it. Just take it as it is. The way first exercise we did, and we were not thinking about giving the name or anything. Similarly, when the name is not given, that polynomial p or maybe q or maybe r, so we will just be taking the expression as it is: 5x minus 4x square plus 3, and we will write when x equals to 0, we will put the value x as a 0. We will do the calculation is equals to whatever answer you are getting, just write answer and you are done. Nothing you have to do. Clear?
Okay, ma'am.
Yes,
Okay, ma'am.
ma'am.
Okay. So the first one and the second one, exactly the same thing, but given in different format. Just that. Any confusion so far?
No,
No, ma'am.
Now we need to discuss zero of the polynomial. Okay, so zero of the polynomial means if I'm taking a polynomial, let's say x plus 4. If I'm taking a polynomial, I have taken a example over here. Px is x plus 4. Okay, And if we are trying to find what is the zero of this polynomial, that means we are thinking that what is that x value, what can be taken at the place of x, any real number, 1 or maybe 2 or maybe 3 or maybe -1 or maybe 2.5 or maybe 3.3 by 7, what can be taken at the place of x, which when added with 4 the result is 0. What can be taken at the place?
-4, ma'am.
-4. Making sense? Okay, x equals to -4 is the zero of the polynomial.
Ma'am,
See,
we can also write it like x plus 4 equal to 0 and then bring the 4 here.
yeah,
Like
I'm
with the
coming to the
transposition
process.
method normally, right?
Yes, I'm coming to the
Yeah.
process, but I want you to realize that what is the meaning of zero. Zero means what? Zero means that x value which can make our polynomial zero. Zero means that particular x value which can make this complete algebraic expression zero. Yes or no?
Yeah, ma'am.
Okay. And yeah, the process says that you don't try guessing like this, because here in such simple question you will be able to guess that okay, x can be taken as a -4, -4 plus 4 will be 0. In such simple polynomial you will be able to guess, but when the polynomial will be quadratic, or maybe when the polynomial will be quite confusing, the numbers, fractions and all will be involved, you will end up getting confused. So process says that just follow the process, you don't have to guess this one,